if I press this button enough times that it will make it better. Oh, whatever. All right. So notes number 3, the normal distribution curve. I am recording this so that I can make a video out of it for you. All right, so many things are normally distributed. Like heights, meaning like if you look at women, like the average height, like most women are about the same height. They're like between 5'2" and 5'4", right? But you're going to have some taller women who are like 5'6", 5'7". You're going to have some shorter women that are going to be like 5'1", 5 foot, 4'11", right? So, but most of the women, if we were looking at women, would be in this sort of range. Same thing for men. Men are generally about 5'6" to 5'8", maybe. And then you've got your taller guys, 6 foot or whatever. You got your shorter guys, 5 foot or below, right? But most people, most men would fall in a range. So that's called normal distribution because they're saying that, well, most of the people are right there in the middle. That's what's considered normal. Usually, weights of people would also fall on a normal distribution. Most people are an average weight of, I don't even know what it would be. I'm not a medical professional. They also say that commute times and I always see like test grades. Those are just a few examples where we kind of get an idea of what's normal because most of the people will fall within a certain range. So like for test grades, I would try to look and see, okay, well, I want most of my students to have like an 85. That would be like a goal for a teacher, is that most students are an 85 or maybe they could get a 90 or an 80, but I want most students to fall within that B range. That would be ideal for me. And then a couple of students will be 90 or above, and then a couple of students might be in the 70s or 60s. But I'll know if there's a problem with my test if everybody gets a 100 or if everybody's below 50. I will think, whoa, that was a too hard test or maybe a too easy test. But as long as most people fall in that 80 range, I'll think, okay, this is a good test. That gives me a good idea of what's normal or what's acceptable. So that's how we generally use this normal distribution curve to give us an idea of what's normal and what's outside of normal. All right, so to create the normal curve, we need two things. We need the mean which usually has this symbol. It's an X with a bar on the top. Or I saw in Delta Math it's kind of this like strange looking U shape. and we need the standard deviation. And the symbol for that is this O with a line on the top. Sigma, we discussed. So what's nice about these problems that we're going to be looking at in Delta Math, they're going to give us the mean, and they're going to give us the standard deviation, and we're going to have to do this next part based on those two pieces of information that are given to us. But we have calculated the mean, and we have calculated the standard deviation previously. It is something that we have looked at. All right, so make some space here. Actually, we'll go ahead and draw the curve. It's called a bell curve. Because it looks like a bell, I guess. Ring-a-ding-ding. And we're going to put the mean in the middle. Now, to go to the right, so this is a number line, and to go to the right, we're going to add one standard deviation. We're going to add it again, and add it again. So we're going to add the standard deviation to the mean 3 times. It's always 3. Just getting some exercise. What if that's my bike? It ain't my bike. Yes. All right. So going in the opposite direction, we're going to subtract the standard deviation from the mean. 1, 2, 3 times as well. All right, so this is just how to create a normal distribution curve given some data. And I'll show you what an example problem looks like and how we're going to answer it and all of that in just a moment. Okay, so we create this bell curve because there is something called the empirical rule. And it says that 68% of your data falls within one standard deviation of the mean. So most people should fall within one standard deviation of the mean. And we'll look at that in heights in just a second. %95 of data falls within two standard deviations of the mean. And 99.7, or almost all of your data, falls within three standard deviations of the mean. And I'll show you what that means for us. But basically, these percentages are going to be our answers in the lesson today. So here's what's important for today's lesson. Now, this probably all sounds like a foreign language to you, but I promise it's not that bad. Are y'all okay? I'll show you how it works. It's kind of like I just explained the rules to the game, and now we're going to play it. It's always easier when you're playing. I hate reading the instructions for a brand new game. I'm always like, what? But it's super easy. Y'all even play games anymore that aren't video games? No. Has anybody played a board game recently? Yeah? Okay. Ian, what are some of your favorite card games? I don't know how to play spades. Yeah. Rummy, I think I know how to. Is Rummy a card game?
Yeah.
I think I've
played it a couple times.
Okay.
Not enough.
You're not competitive with it. No. It's sort of like a little bit of a luck of the draw in a way, but you need to have strategy.
Yeah.
Okay.
It's basically the same way.
Okay. All right. So I've told you the rules of the game. Now here's how we play. So here's an example. Okay. And they are kind of set up as word problems, so get ready. right, so just in case you're curious how many inches tall you are, you're gonna multiply. So say you're 5'6", you would multiply 12 times 5, and then you would add 6 to that. So if you're 5'6", you're 66 inches tall. If you're 5'8", you'd be 68 inches tall. So that's where they're getting that 68 inches. So they're saying that on average at this school, the guys are 5'8". Some are going to be taller and some are going to be shorter, but most of the guys that they got data from were 68 inches or 5'8". So what we do is we start with that mean in the middle. 68, mean in the middle. Always, mean in the middle. Since it says that it's normally distributed, I can use that standard deviation to create a normal curve so that I can make some kind of inferences about the data. So what we do with that standard deviation, we're going to add the standard deviation. Three times. To that 68. So I'm starting at 68 plus 5 would be 73. Plus 5 again would be 78. I almost messed that up. And then plus 5 again would be 83. In addition to that, we're also going to subtract the standard deviation 3 times to the left. So 68 minus 5 is 63. Minus 5 is 58. Minus 5 is 53. Once I create this line of numbers, I know 3 pieces of information for sure. No cap. All right, so 1 standard deviation away from the mean in each direction. Here we added a standard deviation. Here we subtracted a standard deviation. 1 standard deviation away in each direction. This accounts for 68% of our data. 68% of the dudes that they taught to are between 63 inches and 73 inches. Within 2 standard deviations away, so 2 in this direction and 2 in this direction, that tells me that 95% of the dudes that they taught to are going to be between 58 inches and 78 inches. And last, 3 standard deviations away in each direction. That's going to account for 99.7% of our data. Almost all of it. Anybody that's shorter than 53 inches or taller than 83 inches, 83 inches, what would that be? So, 6 times 12, 83, 73. That would be 6'10". So if you're taller than 6'10", or shorter than, I didn't figure this one out, but shorter than a shouty, you're considered an outlier. So you're either considered a giant or you're considered a shouty, because you don't fall within 3 standard deviations of the mean. You're not in this normal distribution. But the types of questions that they're going to ask you in Delta Math looks like this. Question 1. What percent of guys are between 53 inches and 83 inches tall? Oops. I said tall and I started writing class. Well, since they're talking about 53 to 83, well, that's 3 standard deviations away in each direction. So that's going to be 99.7%. So the answers that you give me in this section, what percentages, these are the only percentages that you could possibly answer. It's either going to be 99.7, 95, or 68. So I would answer this question as 99.7. And you do not have to put the percent sign into Delta Math. You would just put 99.7, enter. Additionally, they're going to ask you questions in a different format, but they're basically asking the same thing. They'll say, determine the interval of heights that represent the middle 68%. So they'll have a parentheses and a box, comma, a box, and a parentheses. So this 68% is always 1 standard deviation away in each direction. So I would record that 68% of this data is between 63 and 73. So I would put 63 here and 73 here.